Good morning, all of you. In last video, we discussed some numericals in which we find out the sliding velocity in terms of the pitch line velocity v, sliding velocity in terms of pitch line velocity v. So in last video, we discussed that example. Now we move toward the next example. in this example, suppose the number of tooth by calculation that comes as a 18.27. Now in this case, we cannot consider that number of tooth as a 18.27, as a number of tooth are the whole terms. So that number of tooth now we consider as a 19 tooths, 19 tooth or 19 teeth. Now with this, by consideration of this whole number of teeth, again with consideration of this whole number of teeth, previous calculation now changes, and that previous calculation, that arc of contact changes, and that parameters based on this number of tooth are changes. Now as soon as we consider this whole number of tooth, that parameters based on this number of tooth are changes, and that we should consider. So this example is based on that particular change in, or by consideration of the whole number of tooth, and by consideration of this whole number of tooth, what are the parameters changes that we discuss in this example. So in this example it is given that two gear wheels mesh externally, and are to give a velocity ratio of 3. The teeth are involute form. So in this example, external meshing gears are given with velocity ratio 3. Teeth are involute profiles are given. Module pitch is given as a 2.5 millimeter. Module pitch is given, m value is given 2.5 millimeter. And in this example, it is given that addendum is equal to module. So this addendum now becomes as a 2.5 millimeter, as module is given as a 2.5 millimeter. Pressure angle is given as a 18 degree. Now, and pinion rotate at 90 rpm. And they asked to find out number of teeth in each wheel, so that interference is just avoided. So interference condition we have to consider length of path and arc of contact, number of pairs of teeth in contact, and maximum velocity of sliding between the teeth. So with this, in this example, we move with the given data. Now if you look at this, by consideration of the interference condition, addendum of that first wheel, one of the wheel cut the base circle of that other wheel. With this condition, we draw this diagram that appear here. So in this diagram, this path of contact becomes JK. Now becomes as a JK. Path of contact now becomes as a J to K. And J and K are the points that are obtained by addendum circle, maximum addendum circle cut the base circle of the wheels. With this condition, we obtain this JK length. And this JK is tangent to both the base circle. JK length is a tangent to both the base circles of the wheels. Now if we consider R is the radius of the pitch circle of the pinion, so with a velocity ratio is given as a 3 times. If you consider R is the radius of the pitch circle of the pinion, now this in this diagram, that one of the addendum of the one wheel is cut the base circle of the other wheel. With this condition, we obtain this diagram. So and also that if you consider that radius of the pitch circle is a R, and wheel pitch circle radius now becomes a 3R, because velocity ratio is given as a 3. So this is 3r, it is given. So 3r it is given. This 3r it is given. 3r is given physical radius of the pinion. R is the physical radius of the pinion. Now with this condition we move further. And now in this we have to find out some lengths. We have to find out some lengths, and then we move further. And here we have to find out the number of teeth. Here we have to find out the number of teeth. And as this teeth we can find out by using formula m. That m is equal to d by t. By using formula m is equal to module is equal to this module is equal to d by t. Module is equal to d by t. D by t now is a pitch circle diameter. It is nothing but a pitch circle diameter. D by t is a pitch circle diameter. So we have to find out this teeth. We have to find out this teeth is equal to we have to find out teeth is equal to d by t. Teeth is equal to d by t. M is equal to d by t. And teeth is equal to d by m. So we have to find out this number of teeth by using this formula of module. Now we have to find out this diameter. Module is given as a 2.5 millimeter. Now we have to find out this d. Value. Pitch circle diameter. Now this we can find out by observing this diagram, and then we simplify this. So this now to find out this, first we consider that pitch circle radius of that pinion is r. So 3r is the pitch circle radius of the wheel. R we consider PCD of the pinion. Pitch circle radius of that pinion, and 3r is the pitch circle radius of the wheel. With this we move further. Now we have to find out this AP length. This AP length we have to find out. So to find out this AP length, we use this AP length we can find out by consideration of the triangles. Now find out this length BK. Find out this length B2K. So how we can find out this length B2K? By consideration of this BK. BK is nothing but a addition of B2P length plus this length, plus this Q2K length, and this is nothing but the addendum. So this addendum is given as a is equal to module. In this example, addendum is given is equal to module is equal to 0.25. Now with this now we have to find out this length B2. We have to find out this length B2P. By trigonometry we can find out this. So we consider this triangle, total triangle. With this triangle we can write as a B2K square. B2K square is equal to AB square B2K square b2k square is equal to ab square ab square ab square b2k is equal to ab square plus ak square minus 2 into ab ak 2 into ab into ak into cos of angle included between these two lines. Angle included in between these two lines is a 18 degree. Angle between included in these two lines is a cos of 18 degree. With now we have to find out. Now put the values of these lines. A to k, a to b, and angle in between this line is a 18 degree. It is given. It is nothing but a pressure angle. That is given to you. Now find out this AB. AK. Now to find out this, now put values. Now b to k. Now b to k is nothing but a b to p plus q into k. b to p into plus q into k. So b to p is nothing but 3r. 3r plus this addendum. 3r plus this addendum 0.25. 3r plus addendum 0.25. Now this AB is equal to a to b is equal to this. Now a to b we can find out by consideration of the triangle. By consideration of this triangle, a to b is equal to this. Now this a to b is nothing but addition of this b to addition of this length. So 3r plus r is nothing but a to b. 3r plus r nothing but to a to b. So ab square nothing but a 4r square. 3r plus r is equal to 4r square. And a to k, this we can find out by this triangle. So a to k is nothing but a, this is nothing but r. This angle is a 90 degree. So with this consideration, this length a to k length now becomes as a r cos theta. So this theta is 18 degree. R cos theta is equal to 18 degree. So this a to k is now become as a r cos 18 degree. Now put all these values into this equation, and you will find this like this. So we will get this equation. Put all the values into this. All the values into this equation, and we will get this equation. And after simplifying, now in this equation there is unknown is only r. So by simplifying this equation, we will get this r value is equal to 2.284 centimeter. Now simplifying of this equation, we get this r value is equal to 2.284 centimeter. Now as we find out this r value, we can find out the wheel value. Wheel pitch circle radius now 3r, 3 times of the r. Wheel pitch circle radius is now 3 times of that r. Wheel pitch circle radius now becomes as a 3 times of that r. So this will be like this. R pitch now wheel pitch circle radius now 3 into r, 3 into r. Now to find out the pitch diameter of that pinion, we have to find out pitch diameter is nothing but 2 times of that radius. Pitch diameter is nothing but 2 times of the radius. So it will become as a 2 into r. It will become as a 2 into r. 2 into r. R we calculated here. 2 into r. Now this teeth we can find out. By model equation, model formula. By using model formula is equal to d by t. Model is equal to pitch cycle diameter divided by t. Model is given. Pitch cycle diameter we will find out. So model is equal to d by t. Model is equal to d by t. Model is equal to d by t. So model is given 0.25. D we find out as a 2.284. And now unknown is the t. We have to find out this t here. Like this. We have to find out t here like this. And with gear ratio, as gear ratio is given, number of teeth on wheel is 3 times. Number of teeth on that wheel is 3 times of the pinion. 3 times of the pinion like this. Now here in this example, that number of teeth appears as a 18.27. Number of teeth appears on that pinion 18.27. So as number of teeth are never be in point value, so it is a whole value. It is a whole number. So we consider as a 19 teeth. Now we consider 19 teeth. This value comes by calculation. Now to consideration of the whole number of teeth, now this become changes. 18.27 now changes as a 19. 18.27 now changes becomes as a 19. So with this change of 19, this previous values now changes. Now this with this teeth, pitch circle diameters are changes. With this teeth value, modified teeth value 19, this pitch circle radius now changes. And that we have to find out. Here. With this modified pitch circle. Here, that radius we find out here. With this change in number of teeth, now this radius now changes like this. So 2.284 now changes as a 2.375. 2.284 now changes as a 2.375 like this. And 3 times for wheel that radius now becomes now 7.125 for wheel. This is for wheel. This radius now changes as a 7.125. Now these changes r is equal to, now these changes r is equal to this. These now changes as a 2.375. With these changes, our previous diagram now changes. Like this. So our previous diagram is like this. But with consideration of the whole number of teeth, now pitch circle radius are changes. And by consideration of that changing pitch circle radius, now we draw this diagram like this, modified diagram like this. Now in this modified diagram, this becomes as a points. These are the points. Now these are the points. This to this. Not this to this. E to F. Now these points becomes E to F. And previous points are J to K. Previous points are the J to K. Now these points now changes. With consideration of whole number of teeth from E to F. So by consideration of whole number of teeth, these points are now shifted to the E to F. and this we consider just this particular change in this particular uh, diagram or construction, change in particular diagram or construction, that we consider, and then again we find out the path of contact, arc of contact, and so on and so on. So here in this example, due to whole number of teeth, due to consideration of whole number of teeth, pitch circle diameters are changes, pitch circle diameters are changes, and that we should consider, for our calculation, so with that consideration, previous diagram now changes like this, and with this modified diagram, now we find out the remaining quantity. Now with that modified quantity, we have to find out this AE length. We have to find out this AE length. AE length is nothing but this particular radius plus addendum. This AE length is nothing but pitch circle radius plus addendum. So this pitch circle radius is a 2.375, and addendum is given as a 0.25. So this is the particular length. So BF is again this pitch circle radius. This is again pitch circle radius. It is again pitch circle radius plus pitch circle radius for a wheel plus addendum. Now JB is equal to BP cos 18, AK is equal to AP cos 18. AK is equal to AP JB and AK, J2B and J2B, this length we can find out as AK into BK into this length we can find out BK into cos B2 into cos 18, BK into cos 18, is B2K into cos 18. This BK is a hypotenuse, so BK into cos 18, this length now becomes as a BK into cos 18. So similarly, that other lengths are find out, and that we consider. Now here we have to find out this length. F2E. Here we have to find out this length F2E. For finding out path of contact, that length now becomes as a F2E. As discussed in the previous change in diagram, we discussed that due to consideration of whole number of teeth, that intersection point, that interference point now changes as a F and E. Interference point now changes as F and E. So path of contact now becomes as a F2E, and that F2E now becomes as a this F2E now becomes as a this length plus this length, so this EP and PF, addition of EP and PF, so this will appear like this, EP and PF, and these lengths we can find out by using trigonometry. And just put this value, and you find out the path of contact. So in this example, we discussing that consideration of whole number of teeth, what are the changes in the other parameter, so here we find out the path of contact. By using path of contact, we can find out the arc of contact by dividing by cos phi. the arc of contact by dividing with this cos phi, dividing with cos phi. That number of pair of teeth, now arc of contact divided by circular pitch, arc of contact divided by circular pitch. Circular pitch is nothing but a pi into m, pi into m. M is given as a 0.25. So as soon as you know this arc of contact, you can find out the number of pairs of teeth in contact, Now with this, now maximum velocity of sliding is nothing but maximum velocity of sliding. We can find out this omega pinion plus omega wheel, omega pinion plus omega wheel, into fp. So put this value here. Omega is equal to 2 pi n by 60. N is given. Omega is equal to 2 pi n by 60. Omega is equal to 2 pi n by 60. 2 pi n by 60. So this n is given as a 90 rpm. N is given 90 rpm. So with this value, we can find out this VC value. As a 8.95. So in this example, we discussed that change in whole number of teeth. By consideration of whole number of teeth, what are the changes in the other parameters? And with consideration of this parameter, we have to find out the asking quantity.